And you can, like, if you're far enough away, you can't even really see the surface of the skin, right? So why is that? Why can't you make out the details? Because the resolving power is not powerful enough. Now, if I take two apples and place them right next to each other, and I go far away, those apples are going to appear to merge as if they're one apple. But like when I was close, see, the better way to think about this is take one apple and put one above the other instead of horizontally. Put them vertically, because that's how we're looking at this, right? We're judging the boat vertically, whether it's up or down relative to the horizon. We're not judging it horizontally, right? So if I take two apples and I put one above the other, and I go far away, they're going to appear like they merged into one another. But what you're seeing is, like, where'd that other apple go? That apple must have went over the horizon. The Earth must be a ball because I only see one apple now. And it's the same thing with the light. If you take two lights, and they're vertically spaced, and you send them far away, they're going to appear to get closer because when things get far away, the angle gets smaller, right? So the angle separating these lights are going to get smaller. The top one is going to appear to come down into the bottom one. The top one's going to appear to come down into the bottom one. And eventually, you're not going to be able to distinguish the top one from the bottom one. And you're going to go, what happened to that bottom one? Must have went over the curve. That's what will visually look like.
No.
Okay. So you posted a video at 45 past the hour, which I haven't clicked on. But there's
the point of this?
Yes, but it's at 4:24 past the start of the video.
Okay.
And the RC boat is over something. It's like I can't see half of it or more.
Yeah, I know that.
Yeah.
But this is flat.
My point is, from that moment in the video, without watching before or after, which I have not, from that moment, from 4:24, there is no way that you could zoom in and see the rest of the boat. Period. End of story. You can't.
Maybe
not.
I don't know.
Haven't done it. It can't happen. It won't ever happen.
He's talking about magnification. So magnification.
Right. So all this bullshit about Raleigh criterion.
Well, hang on, dude.
Look, Roll my bull. You're trying to conflate two things. Magnification.
From 4:24 in that video.
No, rolling. You gotta
zoom in.
Rolling. Relax, dude. Go ahead and do it.
Yeah, magnification and angular resolution aren't the same thing, and the ability to zoom in on something doesn't cure it. They're different formulas. They work completely different. Magnification is about the focal length, but angular resolution is about.
We all agree that you could zoom from 4:24 in that video. You could zoom in, and you'll never see the bottom of the boat.
Look, you can't zoom in on things that are beyond the resolving power of the optic. It's not possible.
Or the horizon.
What are you talking?
No, that's just your assumption. That's your assumption. It's
Dude.
not or. It's only. It's not or. It's only.
Look, the
So
point
it's
of this.
the resolving power of the eye or the optic that you're using, which in this case is a camera. There's a resolving power that it has that it can't resolve once it goes past that. And it also, you have to, like, there's a few variables that are taking place here. So, and that's what Indy was talking to you about, but it seems like you just want to negate that and say it's only the thing that you're talking about. And then when he introduced this specific thing, you're like, or it's the thing that we're talking about. It's not or, it's only.
Well, I mean, he's technically rolling my boat. You're arguing against the gold model, and you don't even realize it. Or maybe you do realize it, and you just can't cope with the fact that this boat should be completely visible if the only reason boats are cut off is because of the curvature of the Earth. This boat should be completely visible because it can't be cut off by a horizon it can't be at yet. And if the horizon appears closer, right, it doesn't matter what it appears like. The only point is that here's an optical effect. Here's what we see. A boat is cut off. We know this lake is flat. We know it can't be the curvature of a ball that's 3,959 mile radius, and that this is the physical horizon that this little RC boat is sailing over, that this has to be an optical effect. And the fact that it exists at all disproves that claim that the only reason we see boats do that is because the Earth is a ball. You know this, okay? It's just pure logic. It has nothing to do with anything else. There is an alternative hypothesis. And an alternative hypothesis, I played an audio, that all the Globers agree with, that the horizon is apparent and it's not even a physical location. That's true on on the ball Earth. We don't claim that the horizon is the edge of anything. We've always claimed that the horizon is an optical effect and that is an apparent, and that what we see depends on the conditions of the air. We've always claimed that. We've never claimed that anything looks any particular way because, magic or whatever it is you guys claim, or because it's a ball, because the horizon's a physical location and shit's going over it. We've never claimed that. We've always claimed the horizon is an optical effect created by numerous things. Partially, the angular resolution of the eye. Partially, the condition of the air. Which means refraction, turbulence, heat, you name it, right? Anything that causes an optical effect. And we know this. It's been experimentally demonstrated. There's published papers on it. There's this stuff. There's all these demonstrations by this channel. We know that this visual appearance, right, this observed phenomenon, can happen on not a ball. And it's also been demonstrated on tennis courts and
not a
other
ball.
stuff, on freaking driveways and freaking you name it.
What's worse, Indio, is that when you think about like how the Globers even cling to like fairy fog or Fata Morgana, they claim that there is optical phenomena that takes place at a distance that skews the observer's view at what they see in the far distance.
What's funny, man, like ships go over the horizon, but when they don't, it's a fucking optical illusion. But we can't see the horizon that the ships go over. And like it's just all over the map, right? Really what they're really saying is, I think it's a ball. Any observation, which goes with my preconceived motion, makes it a ball. And just like this, you're like, oh, look, the boat's cut off. I can't conceive of any other way a boat can be cut off other than it's a ball. So even if it falsifies my ball of 3,959 mile radius, I love balls so much it's just a smaller ball. I'll take any ball.
You must really like balls, man.
Yeah. It's in the chin nuts, too.
Wow, we're gonna go to insults now?
Yeah.
Sad.
Target acquired.
Very sad.
You're the new target in about 2 seconds.
You don't want to be next, Brandon.
My goodness.
You can't be first, but you can be next.
My goodness, rolling my boulder. It must have been months. It's been almost a year since we've spoken, I'll bet.
Yeah, see, I knew he'd been
Wow.
here for a while.
Hi, God Rockin'. And
Hi.
Indio, I never made any bones about it. It's almost exactly a year ago when I showed up.
You got a timer? Like,
No, I
That's
just.
an occasional thing. It's his turn. It's his turn tonight. He got caught up in he signed up for this, and now here he is. Well, congratulations, Mr. Boulder.
yeah, you said you claim the horizon is physical, so we can measure the size of the ball by measuring the horizon, right?
Roughly, I guess. Sure. Why not?
So we live on a ball of 315,000 mile radius, right? And with a circumference of 1.6 or 1.4 million miles. Well, like did the Black Swan and that horizon.
4 million miles. What?
That's the circumference of the Earth.
Oh, all right.
Yeah, it has to be because the horizon's 10 miles away from 1 foot elevation.
Sure.
Well, I mean, if the horizon's physical, that has to be the conclusion. That's that's the geometry.
Okay.
See, I mean, it's never like looks like is never going to be good enough. It's always going to have to be. They claim a specific radius, and it has to match it. And if it doesn't, if you're going to just like jump off the specific radius,
You
know what? Do you know what we hear?
Jump off. I don't care about numbers. Go for
Yeah, but they have to be. The radius has to be 3,959 miles. Has to be.
Why?
Can't be any other radius.
Why?
Every single distance calculated off that radius. Every single long distance, like between the continents, airplanes, like the estimated distance between two places on Earth are calculated by using latitude and longitude and calculating radius.
Wait. This
Not
is how
only that, not only that, Indio, their entire solar system
Let me
depends
keep
on
going. I was going to keep going.
But wait, this
it-
Indio, this is how you compute those things? Or
No,
someone
no,
else
this
computes
is-
them?
No, this is how it's
How do you do
computed
it?
in navigation.
How do you do it?
I don't.
Oh.
I don't. Like, why would I do that?
Yeah, nobody here pretends that the Earth is a certain distance from the sun.
Yeah,
I don't
want to
care
get
about
to that.
that.
Though.
I was just asking, how do you compute the whatevers that he was Indio?
Look, if I want to go somewhere, right? I get in a car, I fill fucking gas in the tank, and then I start driving. Like, I don't go, oh shit, it's 500 miles now. I'm not going. Like, oh man, I only put enough gas in. Like I got 10 miles short. Oh my god, I'm just stopping because my calculation was wrong. Maybe rolling my boulder was right. Maybe it is a bigger radius.
I mean, that was Christopher Columbus's problem, right?
Christopher Columbus was lost, and his astrolabe has been tested since then. And he was off by 50. He would have been off by 15 miles a day if he used that astrolabe. He was lost. He got found. He didn't discover shit. He got discovered to be lost by.
He
Indians.
never even landed in North America. He landed in the freaking in the islands out.
I can't believe you just
So
thought of Columbus like kindergarten.
matters.
Fucking hack, man.
It matters how much gas you put in your tank. You don't want to be like Christopher Columbus, right?
Yeah.
He was
Different
using the wind. You're not going to.
Yeah, but does it have anything to do with our distance on Earth from the sun? No,
Yeah, so-
of course not.
Of course.
So okay, so just to go back, right? So they need the radius to calculate the size of an orbit. They need it to calculate the distance of the moon. They need it to calculate the size of the moon. They need it to calculate the distance of the sun, the size of the sun, the distance and orbits of all the planets, the Earth's orbit, the moon's orbit. Then all the stars, all those distances are based upon the radius. Expansion of the universe, yada, yada, yada. The whole story, the entire story, the entire cosmology.
You
is
think
based
the numbers about Jupiter depend
Yes.
on the radius
Yes.
of Earth?
Yes, they do.
And-
I don't
and
think
the
it. I know
light
for a fact.
Yeah, I mean, how could it not be?
I know for a
The-
fact, dude.
The
Yeah,
light years
exactly.
to Alpha Centauri,
Yes.
or whatever,
Yes.
depend on the radius of the Earth,
Yes.
Yes.
and the fuel that I put in my car to get to Denver from Miami depends on the radius.
That's a non sequitur.
Oh, I mean, not
But I mean, all
really
of it's like
because
distance
not
to
really
Alpha
because there's
Centauri,
topography.
size
There's
of
just,
Jupiter, distance to Denver. All of it depends on.
no,
No.
listen, not the distance you actually drive, but the distance that you're going to estimate that you drive. So you'll go, okay, from where I am to Denver is 500 miles.
When you're
And
driving,
I'm
your
going
car,
to
you
estimate that it's going to take me X amount of hours to get there. If it takes you 3 extra hours or 3 extra hours, you're not going to call the fucking U.S. Geological Survey to say, hey, it took me 3 hours. Like, you're not going to complain, right?
You
And
guys
like,
are
how
wrong
much
about
gas
this.
you use depends on your tire inflation, how many hills you drive, the speed you drive, right? Did you wash your car? Like, I mean, there's so many factors that determine gas mileage. How new are your spark plugs? Like, what's your you're not going to complain, oh my God, I freaking used 3 more gallons than I calculated. Holy shit, man. Call NASA. They're lying.
So how does the number of moons around Jupiter depend on Earth radius?
Around you.
It really has
What are you
nothing
talking
to
about?
do with it. That's a pretend idea. Listen, do you understand about anything about cosmology and calendars and how they're built? Of course, you know the moons of Jupiter have something to do with the moons of Jupiter have something to do with Jupiter, right? And it's more spiritual. It's more spiritual than it is physical, because you might think, you know, through your math magic idea that it's
Math magic?
has something to do with gravity. I mean, it always comes down to gravity. It always doesn't it?
Well, yeah, gravity holds everything together,
All
right?
right, so
No.
Well, the strong and weak nuclear forces kind of do that.
If that's the case, then show
Okay,
us gravity.
so
Show me the gravity that
I have a
talking
cup
about.
of water. What's holding the water together?
Gravity.
Oh, it's not the electrostatic bonds in the atoms and molecules. The gravity.
It's gravity.
Wow.
And so you could say,
Wow,
you guys
dude. I
deny
should kick you off the
gravity.
server for just
They're going to
fucking
discount
being that
everything that we say, India. He's going to discount everything we say, but saying he can tell everybody, oh, don't even fuck with those guys. They don't believe in gravity.
So atoms and molecules are held together by gravity.
Before I ever... Come on.
Atoms and molecules are held together by gravity.
No. All right, see, now we're getting somewhere.
Nuclear force.
Well, technically, the protons and neutrons are held together by nuclear forces, but the atoms and molecules are held together by electrostatic forces, chemical bonds. These chemical bonds
How
are
does that
electro-
disprove gravity, though? That's just something
No,
else
it's
to hold them
just
together.
proving that everything is held together by gravity. Gravity
it doesn't
doesn't have to be disproven; it hasn't been proven, so it doesn't have to be disproven.
Well, like, there's a theory of gravity where 2 masses attract each other, right?
Yeah, that's cool.
Yeah, but it's been
Mass
tested
attracts
through
mass.
universities.
Oh, it has.
That's been yeah.
Yeah, when was it tested?
Oh, I don't know if you get like
The
a
Cavendish.
Now I gotta go.
if you got like an engineering education, it's one of the labs that you do.
Oh yeah, cool.
We've done it at my school.
Yeah, at my school, there's a lab on how many angels fit on the hand of the pin. I did a calculation. It's Clark 3 2048.
Angels?
Yeah, angels that fit on the head of a pin. Yeah,
Wow.
I did a calculation, man. I did it in angel engineering school. So yeah, it's true. That's how stupid you sound, man.
I'm gonna.
No, it's done in labs. Like everyone can see what's going on.
What's
Yeah.
done
So,
in lab?
like, no, so let's-
Since
Proving
you
that 2 masses attract each
you're
other.
convinced by this, Roland
So you
Mello.
did a
What is
calculation,
done
and
in
that
lab?
proves 2 masses
What's done in
calculated.
lab?
What did you calculate in the labs?
Yeah,
force
what's
between
done
two-
in labs?
Yeah, so okay, so you calculated something, and what did you experimentally test to verify that calculation was accurate?
In the lab.
Well,
Well,
what did you say?
would you experimentally test to verify your calculation was accurate?
Well, the what's it called? The force that we calculate between the 2 masses is what we can use it.
Let's
we can use it.
calculate how many times
Hold
he
on,
says
let him finish,
we.
Helio. Let him finish, because he's about to shove his foot in his mouth.
All right.
Yeah,
We can
so
get-
you're
we can get the,
calculating
we can
what?
get the gravitational constant,
Yeah,
right?
In the
You know,
report.
I'm assuming you know. Yeah.
yeah.
Yeah,
So
why from there-
tell me all about the Cavendish experiment, because yeah, that's where you're gonna go with it, right? The
I'll give you-
Cavendish experiment.
The cabin.
Well, you could go to the Schehelian experiment.
I'll just make sure it's still in the laboratory.
Brandon, back away from your mic, bro.
Yeah, dude. Stop
Okay.
hitting your mic.
Sorry.
Dude, put hot sauce on it or something.
Don't steal
Tastes
my
good
shine.
though.
Yeah. Don't steal my shine.
We're getting into the Cavendish or whatever.
Yeah, I mean, it's just like boring, but
The
whatever.
Schehelian experiment.
In multiple argument, but I mean, we
Well,
might as well
so-
go through it again.
So you claim we calculate the big G, the gravitational constant, from your calculation. Where did that come from?
No, we get the force between the two, and then we can get G.
Yeah, how? Describe it to me.
Describe what?
Describe it to me. Describe
what?
what you did.
But
Dude, what are you talking about?
He doesn't know what he's talking about. He's trying to.
No, he's gonna say we. He's gonna say we did it. We did it.
No,
we
no.
did.
I'm asking him
We,
what
we,
he's talking
we.
about. Cause one
No, I
second
didn't do
after
it.
he finished saying what he said, he doesn't even know what he just said. He's like, "What do you mean? What?"
Yeah, he doesn't-
no, I don't know what he's trying to get at. I don't know why he's asking.
You said that you can calculate G from calculating the force. I'm asking you how you did that. I don't want the
Cavendish
formula.
experiment.
Yeah. Oh, the Cavendish experiment. What is observed in the Cavendish experiment exactly? Tell me.
Force between two masses.
Yeah, how is that force measured?
Anything, bro. I don't know.
You don't know.
Anything that calculates force between two, or anything that measures force.
You don't
Like
even
what?
know what the Cavendish experiment is. Like, do you know anything about it?
I know it roughly. I don't really haven't
Roughly.
studied it.
Do you know what dowsing rods are?
No.
Dowsing rods. So it's like they take two bent pieces of metal and they walk around to try and find water. And when the dowsing rods come together, they say they find water. Is that gravity too?
I don't know.
The
what
rods
you're
come
talking
together because of the attraction of the masses of the dowsing rods.
That
That's
actually
just how
kinda works.
stupid fucking
That
Cavendish.
actually kind of works. I've seen some videos where that.
Yeah,
actually
I know it works. Maybe it's the masses of the water or something. I don't know.
Yeah, but the torsion bar. I mean, that's what I thought you were gonna say about something about the torsion bar. And the,
No. I just like trolling with the dowsing rods because that's how like stupid Cavendish is, man. Because seriously, because
Wow.
you can set up a Cavendish and you basically flip a coin on whether it'll work or not. And I'm sorry to tell you that, Potter, that the so-called experiment is so unreliable as to be humorous.
That's fine if it's unreliable to you guys.
No, it's unreliable to mainstream science. It's not me. You want a video?
Okay, do you have a citation for that? Do you have,
I got a physicist, PhD, university professor showing how they. What do you mean? No, I don't.
Oh, my fault, bro. I thought you had the PhD. Hey, go on.
the Cavendish
I thought you said you had
experiment
the
is
PhD.
unreliable in every situation. That you can't make it work. That's what I want to
No,
say.
I didn't say that. Unreliable,
the
as I
thing.
mean, you get spurious results.
yeah, here's what I think about.
Inconsistent. It's unreliable.
They use it in high schools and lower collegiate observation. They're like, let's do a mini
But
test
it's not a lower
right, in a classroom. There's just like, oh, well, haven't you all done this before? You know, when you're doing a science experiment.
I just think it's funny when they
It's so
cite
dumb.
Cavendish. They don't even know.
Is
what
it
the-
unreliable or
But
does
we
it
do
get
a
more
mini
precise?
Cavendish experiment
No,
right
it's
here in the
unreliable.
classroom.
No, that's not what we do. That's not where we do it.
Really? Well, then
No.
how the fuck do you do it?
Well, you know, like
Doesn't even know
90%
what
of
it
the
is.
you know, 90, like most of the science comes out of universities, right? Like
Yeah.
all the,
So what does that mean?
That's
What-
where the labs come from, right?
Most of the science comes from
Okay.
the
No,
academic.
like most of the
Well, that's
research
good.
comes out of schools.
That's
They
awesome.
don't-
Because that's awesome, Father. Because you know what I just posted? Did you see what I just posted? So this guy,
The video.
he teaches. Yeah, this video, this Cavendish experiment. This guy, this is at a university. It's at Cambridge in England. This guy is a physicist. He teaches physics at the university. He has a scientific grade Cavendish apparatus, and they can't get it to work. And they get so pissed at it, they saw it in fucking half. Okay? So a physicist at a university with a scientific grade, not a chop shop freaking Cavendish experiment, one they bought for like $1,400. And it don't work. Why don't it work? This isn't the only one. I got Christmas bulbs.
Probably because you didn't go to Fauda school. At Fauda school, they do it right. Right, Fauda?
School, like every school, as long as
We're
you.
Canadian.
Here's another one where it don't work. I mean, I can do this all day, man.
Yeah, but it's just like if you add school upon school, you'll be more understood because you're a scholastic.
Here's another one where they just change the orientation of their so-called masses and then get different results. They don't change the masses, they just change the way they're oriented. So, Brandon, this is what I mean by unreliable.
You said different results.
Here's
Yeah.
4 different examples of Cavendish setups. 4 different ones. Using the same principle. They all get failures. Or some, like the Christmas bulbs, it shouldn't happen at all.
Yeah, because they're not solid.
No, but that video that you sent, 17 minutes after the hour, it's working.
Wait, are Christmas bulbs solid?
That's the point. It shouldn't work. No,
Why?
Christmas bulbs are not,
No. What do you mean
because
shouldn't
they're not
work?
heavy enough, dude. Because they don't have enough mass to work. They're Christmas bulbs are hollow glass. You don't.
Yeah, you just explained
No,
it.
no,
You
I'm
just
not talking-
explained
I'm not
why
talking
that
about the
Christmas
Christmas
bulb thing
bulbs.
didn't work.
I'm not
Because
talking
they
about
don't
the
have
Christmas
enough mass to walk.
Wait, is that something working laterally? I don't even. I'm trying to understand this. Are you talking about
Brandon, your
something
microphone's
laterally?
getting bad, dude.
Yeah, in the second one, Cavendish experiment time lapse. Read the description. It says, due to environmental problems, air conditioning turning on and off, and vent blowing in the apparatus, results from the experiment are compromised.
Yeah, this is not.
Then you
3D.
got the next one, tilt washer Cavendish experiment. They change the orientation of the washers and get a different result. So the point is
Right,
that
it says here's a revised, improved version.
Still has nothing to do with gravity.
yeah, listen, dude. Do you know what cherry picking is?
Yeah.
So you have something you want, right? So
I know
a
what
result
cherry
you
picking
want,
is.
and you keep testing until you get it.
Yeah.
Yeah,
That's the whole white swan, black swan bullshit.
no, it's not the what. What are you talking about?
Yeah, that's what you guys cherry pick.
You think that? Are you serious?
Anyway,
cherry
anyways,
pick
go
from
on.
what?
Yeah, that's
So
what he was looking for the entire time. You see what
What's
you
the
see.
sample size? You just fucked up. You just seriously fucked up. Out of how many samples is the black swan cherry picked out of?
I don't know. But
So
there's some times where you can see, sometimes where
Once.
you can't see, but you guys cherry pick
One.
what you can see.
No, once.
No, it's
There's
once
one
it's
time.
documented.
Yeah.
No, I have another photo from it.
And there's 13 times where it's just like the black swan. And once. So you're the one cherry picking.
Okay, but that still
No,
disproves it.
once
If
it's hidden.
it works
So
once,
once they're hidden.
well, it's gonna
13
be.
times they're not hidden. Who's cherry picking?
So then you can't use it then if it's
Why?
if because at some point it disproves you, right?
If it's only
No,
once.
it's called
If it
it's called
disproves
an
you,
anomalous
If we
result.
can't use it, you can't use it either.
It's begging at this point.
No, listen.
No, I'm
now
not
you're trying to
begging.
move the goalposts. Now we can't use
Yep.
it. Are we cherry picking or not? You're cherry picking.
Okay, we're cherry picking, bro.
No, you're cherry picking. There's
Yeah,
no
that's-
we. Who's,
That's
who's
what I
we?
said.
You have
No, you
12
said we.
bullshit
Go
points,
over.
and the 13th one
Wilbert.
kind of destroys it. Anyway, that's so stupid, man.
It's actually more than 13. I just have 13.
Yeah, I mean, there's 113, but he makes himself look like
I'm
a
just talking
fool.
about the oil rigs. I'm just talking about the oil rigs taken with that guy from that camera from that location. There's 13 videos. There's that one video where it's cut off. Half of that video is one thing, half of it's the other. In all the other videos, every single one, all the observations in all those other videos, which is actually more than 13, show the horizon is too far.
Dude, I bet every single one of us, if we could go to that shore and we could actually recreate the same exact video every day. We
And
could do it.
on top of that, there's Pablo's dog, who goes and takes video from the same location or that same harbor in Santa Barbara from the University of California, Santa Barbara's parking lot. He's been doing videos like 2 or 3 a week for about 6 months.
Yeah.
He's taking not just those 2 oil.
Stefan. And let's watch this video and see what's going on with it. Okay, wait. I need to unmute it.
The torsion balance come to rest over the course of about 24 hours now. Even with that amount of time, I think just from the air circulation from the heating and cooling system, I've still seen a small amount of motion here. So in the last about 10 minutes, I've seen this end move from here over to here. So that's probably about 10 degrees in 10 minutes. I'm going to let this, I'm going to just gently touch this and try and bring it to rest and observe for another couple minutes. And then whichever direction I see it moving, I'm going to put the bowling balls that are my other masses on the opposite side as that, just so we can verify that there actually is a change in direction, a change in the direction of the acceleration of these things as they rotate. I don't think we're going to be able to get it to a position where they're totally stopped initially. So this seems like the best way that we can still verify that there is some force from gravity between the masses I have on the ends of this meter stick and the bowling balls that I'm going to put in place.
You're not doing it correctly.
Very gently.
If I'm not mistaken.
Just trying to stop any motion.
You're not doing it right. You have L flow. Those. Wow. Okay. And this guy contradicts himself too. It's weird. Let's listen back to see what they're talking about.
This, it was just like, I just wanted to scream at this stupid asshole. But yeah, so anyway.
Yeah, I mean, I'm trying to stay calmer. I don't know.
No, man, it's just like, how many times have we banned Roland Boulder before? You remember this asshole?
Yeah, I
he's
know.
been on. Yeah, I mean, it's just like.
I think he's banned. He's probably on the perma-ban list, Ro. I know.
He might be, but it seems like I'm a reasonable guy, you know. And it's just like everything he says doesn't make sense at all. So it's just like confusion on top of confusion. Really doesn't even have to do with a lot of things that he says has nothing to do with flat or globe.
No, they're confused. They said it themselves. They're confused. And, yeah. I get why they're confused. I totally understand.
Something about the solar system.
So check this out. I was thinking about this morning. No one ever has ever, history of mankind, nor is there any fake video showing it, has ever seen the complete orbit of one body and around another body. Not even a fake one.
Yes, I'm going to give you an amen on that one. Yes. Dude, I think about that all the time.
So whenever they bring up moons of Jupiter, I'm like, no one's ever seen the moons of Jupiter orbit Jupiter, right? They only see them like go across one
cycle. Some of them disappear. They move back and forth.
Well, for all we know, they're going like a big looping circle right in front of it,
Could be.
No.
No.
Ew. Yeah, that's gross.
Yeah, I mean, Jupiter is, dude. How about you consider this, India? Jupiter, that's a god. You know, I mean, just looking, you know, in the ancient culture, that's a god. But then I don't know how they would have seen the moons of Jupiter, right? But Jupiter was a god to a lot of people, right?
Wow.
I'm not saying you should.
Yeah. Who were you talking? Weren't you telling that to somebody and they were like, I don't care what the names are? Or something?
I know. I mean, shit, I talk about it all the time. So
yeah, like that's not important, right? Like, no, someone was trying to like hand wave dismiss you or something. I think I was listening on YouTube, and you brought that up, and they were like, I don't care what the other people used to call it. Like they just didn't care.
I think it's very important, though.
I do too.
Especially when it comes to the moons of Jupiter. Now, you know, in ancient cultures, maybe they didn't have the telescope. They couldn't see the moons, right? And sometimes if you watch the moons of Jupiter, they do disappear and they reappear. Just like our moon during the new moon phase completely disappears during the lunar eclipse, right? And if what they claim about the moon being physical, wouldn't you see it approaching the sun? I mean, you definitely would. you definitely would be able to. If it was a physical object, you definitely see that moon approaching the sun during a lunar eclipse. I mean, yeah, I don't mean during a solar eclipse. I'm back. Anyway. But either way, you're going to see both objects. It's a cycle. I mean, even with Jupiter, with the moons, if you're paying attention to what Jupiter has going on, there are several moons there. They move in different positions. Sometimes you see some of them. Sometimes you feel like a nut. Sometimes you don't. But yeah, it's kind of weird. It's like Jupiter has something to do with us, doesn't it? I mean, is Jupiter a god? One of the gods? Maybe.
But what would like the logical reasoning behind one of Jupiter's moons disappearing be, and then reappearing after a certain amount of time?
I have an idea.
I mean, you have Titan. Titan is one of Jupiter's moons, right? And
I'm not sure.
Yeah, there's different names for
You
Jupiter's
think orbits is a logical reason?
and it makes you kind of wonder, like, if they didn't have these telescopes, back in the day, how did they already name the moons of Jupiter?
So let me get this right. Orbits have never been observed.
Mm-hmm.
But orbits are a logical reason.
These ancient cultures already had names of Jupiter's moons.
But that still doesn't explain why the moons disappear and then reappear.
Mm-hmm.
So your reason is orbits, right? That's the reason. Orbits.
Oh, well,
that's never been observed. What if I say something else that's never been observed, and I just fill in my story?
Yeah.
For the
Alright.
story.
It's gotta be
And
logical.
I'll just say
but give me a
there's
story.
no, that is logic. It's the same logic, dude. That's what I'm trying to point out. That orbits have never actually been observed. In reality.
Why do we see the sun? Why do we see the sun move across the sky?
We do see the sun move across
Why?
the sky every single
Why?
day.
Because it feels
Why?
like it. That's a metaphysical question. Why?
It's the reason
Because
you
it does.
see the sun move across the sky every day is because it does.
It's because it does. Just because.
Because you're like a child.
That's not an
Why?
asshole.
What do you mean why? That's what a child asks.
Yeah, but because it does is also an answer.
What's the cause?
Children,
What's the cause of it?
Because it does is the answer I'd give a child.
What's the cause of it?
Why? Because
What's
if
the
sun
cause
doesn't
of it?
And I
Okay,
feel
sun doesn't have a
comfortable, like,
motive.
sitting in a
It doesn't
recliner.
say-
I'm like, oh, I watch the sun move across the sky every day. I'm like, hell yeah, that sun is a badass motherfucker.
Okay, what's the
What
cause?
is the cause of it?
Okay, I have a better idea. What experiment can we do to determine the cause of it?
Could-
Yeah.
Thank
you very much.
You're not answering my
We want to
question.
know what causes the sun to move across the sky. I'm going to do an experiment to figure out that cause. How do I do it?
What's the cause? You have to answer. You're not answering my
I'm
question.
asking you what experiment I can do.
Well, you don't know?
Well, I'm assuming, like, if you think it's something else, then you must have done that experiment, right? So what's that experiment?
Yeah, if you
Well, you're talking like you
Well,
have
we don't
so
need
much.
experiments. We're going to make up stories in our fucking head.
sure, if you're sitting in a chair and you're just watching the sun rise and sunset, and you have an idea about why you saw the sun rise from the west or from the east and then set in the west. I mean, what? No, I mean, if you had a philosophy
obviously, in
or an
experience.
idea about it, let's start from the beginning. Do we have to start from the beginning, India? I don't even.
It's Apollo dragging the sun across the sky. That's what it is.
Well, you're speaking with so much authority that you know. Well, what's the cause of it?
I didn't say I know that. I'm saying there's no experiment that can tell you the cause of that. And because there's no experiment, there's no objective claim.
So we can't use a gyroscope?
Hey,
At all?
you're just smart. You're as smart as me.
Whatever you want.
Yeah, you're as smart as me, and you're as smart as everyone else in here. when you see the sun move across the sky from the east to the west, if you say, why is the sun moving from the east to the west? You know, that's where we begin. This is babysitter, like freaking original level shit. Now, someone can like come up to you and say, well, the reason that you see this is because you're living on a globe and you're spinning around, and you'd be like, God damn, that sounds weird. All right, so I'm living on a globe, and the only reason that I see the sun moving across the sky is I'm moving towards it to the east, and then I'm falling around the globe, and then I see it rise in the east again the next day because I'm still sitting in the same place.
Are you only accounting for one movement, or two, or how many movements are there?
I don't know, if we traced like a path for like Helio's body through space over a week period, it would be all squiggly, swirly, spiraling. Dude, imagine that, dude. Someone like, you know how you've seen like the solar system GIF, right? With them spiraling. Now imagine if they had a person, right? You on there, right? And they just traced your path, spinning ball through.
Yeah, I mean, and that GIF with the sun traversing the Milky Way galaxy with the Earth and the sun, moon, and stars, like traveling around, you know, and the solar system traveling around, you know, through the Milky Way galaxy. It's just like, hey, but hey, I'm standing still. I'm
here. The rotations of a tilted Earth with that, dude. It'd be fucking all over the place.
Bro, I mean, don't even get me started on the 23.3.
Yeah, here we go again. I mean, Brandon, like, I understand that you like the heliocentric story, man, but, you know, the facts are the facts. The facts are the stories. Even Copernicus admitted that there's no way to attain the true causes of whatever the celestial bodies are doing.
Well, at the time, there wasn't.
Well, why is it so hard to believe that?
Why is it different from that
giant fire?
What do we have that Copernicus didn't have?
Spaceships, technology, computers, everything. We have what you're speaking on right now. Are you serious?
Oh my god!
Computers, light bulbs, lights, gas, glass, telescopes. Then may I go on? Soda cans.
Great, dude. Great, yeah. But that's not what I meant, dude. What I
meant
was for determining the true causes of the celestial phenomena. What do we have now that he didn't have?
Gyroscopes, telescopes.
Oh, a gyroscope. So I can determine the cause of the sun's motion with a gyroscope.
Well, if it's a precise enough one, yes. Actually, Flat Earther did that.
Pardon? Say that again? I didn't hear you.
Flat Earther, you know Bob Nodell?
Oh, jeez. God, yeah. You're not that.
But is he?
Yeah, that sucked for Flat Earth.
No, you're just a fucking retard, dude.
Oh, God.
No, hold on, dude. So, Brandon, tell me, how do you measure 15 degrees per hour with a single-axis gyro?
So, was that a single-axis gyro Bob had?
Single-axis fiber optic gyro. So, how did he measure 15 degrees per hour with a single-axis gyro?
Actually, there's a video of him showing...
I don't care what he said.
I think it was Nathan Thompson that it was measuring on 3 axes.
Hey, would you be interested if I could show you a video where Bob explained what happened on that Netflix interview? Would you be interested in listening to that? It's about 15 minutes long. Do you want to listen to it?
I'm interested in seeing it. Yeah, can you send me the video?
15 degrees per hour. Is that the sum of the 3 axes?
That measured? Yeah. That measured the 15 degrees, yeah.
I'll post it here, but you know,
you're just making things up.
You're gonna have to watch it. I don't think he'll actually watch it and take it.
You don't care about Brandon. Don't care about the fucking truth at all. He'd care less.
I have the video saved, and I share it all the time, just like we all do. You know, Bob's been here several times. explained what happened with the Netflix interview. It doesn't matter what.
So when they put the fiber optic gyro in the vacuum chamber and it read something like I think it was 6 degrees per hour rotation, did the Earth stop spinning?
They explained that. I think the explanation was it was the ether that did that.
Well, why? What is the globe explanation? If your hypothesis is gyro measures rotation because the Earth is spinning, if that rotation changes, that means the Earth's rotation had to change, right?
Well, go ahead and post that video. I will definitely watch it.
Yeah, that's what I thought.
Hey,
Right.
I think you should take time to watch it. I'm posting it in the live stream voice text right now.
Okay, 24. Okay.
All right, so
I see
Bob, no, if you had the opportunity to talk to Bob, which we have many times about this, what would you ask him? And he's come into this room, same way that you have, and explained it. And I recorded it, so you can listen to that video and get his explanation for it.
Yeah. And
Okay.
the reason Bob says the ether is because, do you know what a fiber optic gyro actually measures?
Motion?
No, it actually measures, well, secondarily, measures the phase shift of light. That's what it measures. It doesn't measure motion per se. But there's all sorts of phenomena that cause phase shift. One being it's called the Aharonov-Bohm effect, where if you put a photon or an electron past what's called a vector potential of electromagnetic field, it'll cause a phase shift. And it doesn't even have to be inside. So you have an electrical solenoid, which is basically a coil of wire. And outside that coil, there's no magnetic field. Technically, there's no magnetic field. There is mathematically. It's something they said was non-physical called the vector potential. And Aharonov proved that this vector potential can cause the change of phase of light and electrons. Right? And this is exactly what a fiber optic gyro measures. Measures a phase shift from going in one direction to the other. So his claim about the ether is not actually far-fetched. Because the Earth has a moving magnetic field, I hate to tell you. And there's a possibility that could be rotated.
Yeah.
So when the field line crosses the direction of the gyro, the light is going in two different directions. So if it's going east to west, would look like it's measuring a rotation, but it's really just the phase of the light's being shifted from being against a moving magnetic field. So what most people don't realize is that a change in a magnetic field creates electrical current, and a change in electrical current causes magnetic field. It's the change that causes it. It's not the actual. It's the change or motion.
Motion.
That
Anyway,
doesn't mean
that's what I
it has to be
said.
rotating, though, does it? It could just be moving.
It just has to be moving. And the only reason it's detecting, but all you're doing is you're measuring a phase, okay, the light has an optical path which are supposed to be the same length, right? But they're going in counter directions. So one's going clockwise and the other one's going counterclockwise. If you have a magnetic field move across this, you're going to get a phase shift, and it's going to be a phase shift because one's going in one direction. It's moving one way against the magnetic field, and it's moving the other way against the magnetic field because magnetic fields have poles. So one is going to.
Okay, let's watch this video and check out what Bob Nadell says.
Okay, so obviously you don't know me, right? You only know me because of what you saw in Behind the Curve, correct?
Yeah.
Okay, and from what I said in Behind the Curve, you took that and interpreted as, what I was saying is that the Earth was spinning, right?
Yeah, you said 15 per 1 hour and 15 degree drift.
That is correct. That's exactly what I said. And you know what? I wasn't lying. That's exactly what we registered. The problem is what the producer interpreted that and actually cut the editing to make it look like. So would it surprise you if I told you that, I completely agree with everything you just said. I absolutely did say that, but unfortunately, because of the way the producer twisted that around, I was not saying 15 degrees per hour of Earth rotation. Now, do you want to know how I know that?
Because your gyroscope, your like $40,000 was, like, how much was it?
Well, first of all, it wasn't my gyroscope, and second of all, I didn't do the initial test, but I got credited with that, so I'm just gonna wear it, okay? But we took that gyroscope, and like I said, when we first plugged it in, we got a 15 degree per hour rotation, and actually, it wasn't specifically 15 degrees per hour. It would be an interpolated value, taking the sine of the latitude times 15 degrees per hour, which would kind of equate out to that. Okay, so let's make that perfectly clear for one thing. But secondly, when I was in the movie, at that time when I stated that, I had no idea. I was just as surprised as anybody else, and I was very reluctant to accept it because I was trying to interpret, exactly what we were seeing. And I came to find out later on, and by the way, I did tell the movie producer this, exactly what we were seeing had actually been measured and discovered over 100 years before in what was called the Michelson-Gale experiment, right? The rotation of the luminiferous ether. So at that point, then what we were faced with is we had the challenge of, well, how do we prove that it is not Earth rotation and was in fact the luminiferous ether? Now, some people, and I'll even say even in this panel, don't believe necessarily that the luminiferous ether exists, but there's also a lot of Nobel laureate, physicists that say that it does, and it's, there's a big debate on it. Let's just put it that way. But by using that very same gyroscope, whether you believe in the ether or not, we actually devised a way to tell us whether or not it was in fact Earth rotating, okay? And it was really pretty simple, right? So first of all, do you understand at all how the fiber optic gyro works, how laser interferometry works?
Well, not really, but I get the gist of it. I get how a gyroscope works and how the gravitational pull works on it. And then when there are spins, there's different. It marks one spot, and then it goes to. It calculates the time interval it takes. Then it calculates the angle. How much is the angle is changed?
Well, that would be for a gyroscope, yes, but a fiber optic gyro works a little bit differently. It works on something that's called the Sagnac effect. And the Sagnac effect is basically, it goes under the assumption that if light is traveling through a medium, right? In other words, they speak of light as a wave, right? So you have to ask yourself, well, what is a wave? What is it waving, right? What is it traveling through to cause that wave? What is the medium that light is actually waving, right? Well, scientists have been saying for centuries that it is in fact this luminiferous ether. And that is what I actually wound up claiming that it was that was actually rotating, the luminiferous ether. Now, here's how and why I came to that conclusion.
Light is a wave.
I can fake an accent, but you can't. You're not going to be able to recreate my voice, my original voice. And the same thing goes for Indio and all the other members here. Nobody can fake being that person. Weird.
Oh, I get impersonated all the time. So.
Oh yeah. Well, as a matter of fact, don't tell anybody. I recreate God Rockin's persona, and I go to different servers and I act like God Rockin. Don't tell him.
I'm gonna join the knitting server and just bitch about how much I hate it.
Oh.
Now remember to spend 18 hours a day there. Don't forget.
Yeah, and make a sock account, and I convinced other people.
Bring back their secrets. Bring back their secret diagrams of the knitting circles. They
So, Brandon, did you watch the video then?
I just got through a quarter of it now, and I'm at the part where it says light propagates as a wave, and that's not necessarily true. Sometimes it looks like a particle, sometimes it looks like a wave.
Well, it doesn't matter what light looks like. We only perceive light with our eyes, right?
And sometimes we perceive it as a wave, and sometimes we perceive it as particles.
No, you can't perceive it any other way than you perceive it. Now,
light.
Describe what the double slit experiment did.
All right, go ahead. So now with your own eyes, you only perceive it one way.
It's like see-through. It's like glass. You can see through it. You can't see it.
All right, cool. But hold on. Can we agree that light is only perceived with your natural eyes one way? You just see.
It's been seen as a particle, and other times it's been seen
You don't
as
see
a
it
wave.
as a particle or a wave. You just see what you see.
No, you
in
see
reality.
because of light. You don't see it. You see because of it.
You don't see light. You know, of course, yeah, you perceive light. I'm just talking about when the reason you can see is because there is light.
That's what I just said, yeah.
This is a bit of a red herring, to be honest. The
Nah,
relevant
it's not a
part
red
of the
herring.
video from Brandon, the relevant part we wanted him to understand from the video was that the gyroscope gave varied readings so far as the rotational rate of a spinning globe.
He said it was the ether that did it, but I don't know.
Yeah, you claimed it as evidence, though. Flat Earther proved rotation.
Wait, what is the name of the ether? I can't find it online. I don't know.
Luminous. I can't remember. I can't say that word. Luminous something. EITHER. I think it's spelled. I'm not sure. Ether.
It's AETHER.
Yeah, but what does that have to do with what does that have to do with visual perception?
No, I just wanna. I've never heard of it before. I just wanna read about it.
I've heard about it quite a bit, but I'm just not understanding where light is involved in ether. I do, but I'm just. I want to see where you guys are going with this, because as far as visual light, what you can see, if you're not blind, which a lot of people are. There's not very many people. Most of the population of Earth can see with their own eyes. Some are, can't see everything all the time. Dude, I actually have presbyopia. You know what that is? Presbyopia. I'm going to be 50 years old in June, and so I have to wear reading glasses to read something up close. But for the most part, my vision is pretty good. So tell me about this. What you guys are talking about? We're getting into the ether now, right?
No, I just want to know what it's called. I can't.
Well, it's AETHER. I mean, I think he just spelled it out for you.
Well, no, that's just the ether. But what is the ether? Like, it says something luminous. Something.
Oh, you tell me.
Luminescent.
No, that's what I'm trying to. What is it called?
I think it is luminescent. I think it is luminescent.
Can you give me the full name of the ether? Like, I just want to do research on it. I don't even know what it is. It's my first time ever hearing it.
Yeah, I've heard about it before. I'm just wondering if someone else wants to talk about it. I can expound on it, but I won't.
Wait, so what is it called? Though? What is it called? What is it called?
The fabric. I would call it the fabric of the universe, but I'm not going to expound on it. I want you guys to freaking talk about it.
No, I don't think you understand my question. Like, I'm just trying to get the name of the ether. Luminous something ether? Is that what it's called?
Luminiferous.
Yeah,
that's what some people call it. That's what I'm saying. I mean, you guys talk about it. I want to hear more. You guys talk about it.
Luminiferous ether.
I don't know what it is either, so I would like to know exactly what it is.
Luminiferous means to emit light, so they're saying luminiferous ether. That means ether emitting light.
Well, no, I just never heard about it. I just wanted to know the name of it so I could read about it.
Oh, well, I can send some links while you guys expound upon the luminiferous ether.
Send some links.
Witsit jumped in for like, didn't he jump in for like 2 minutes? He's like, I'm here, and now I'm gone. Which is cool, but he got a new baby, and him and Kai. Man, that was so cool that Kai jumped in. I didn't even know it was her. That was so fun.
Yeah, I verified her.
Yeah.
Alright, I'm gonna continue watching this video, and then I'm gonna end this.
So we went back and we looked at these experiments from over 100 years ago and the assertions about the Sagnac effect and laser interferometry. And it turns out that what they say about the luminiferous ether is that it rotates very much, or it behaves very much like a magnetic toroidal field. Are you familiar with a toroidal field in a magnet?
Yes.
Okay, so the ether very much behaves in the same way. It actually is moving. It's not a stationary thing. It is moving, and believe it or not, it propagates vortexually, right? And it just so happens that vortex rate is about 15 degrees per hour. Now again, how is it that we were able to figure that out and that it was not Earth rotation? And the answer is really quite simple. So if I'm taking, and this is, by the way, exactly what we did. So we took the fiber optic gyro and we went to a place in Colorado called Pikes Peak. And Pikes Peak is at 14,125 feet above sea level, okay? And we did our measurements there, and we got essentially our equivalent to the 15 degrees per hour rotation rate from Pikes Peak. Now again, whatever you want to call it, you can call it the ether or you can call it Earth rotation, whatever you want to call it, that's fine. But what we're trying to prove here is that it was not Earth rotation that we were picking up. So we did that measurement at Pikes Peak and we got a value for it, okay? And then we went down to eastern Colorado following the exact same line of latitude, right? And why we followed the exact same line of latitude, I'm going to tell you here in just a second. But we went directly east in Colorado on the exact same line of latitude down to just over 4,000 feet. And then we did another measurement, okay? So would you agree that if I am measuring something that rotates, or that measures spin, right, or a rotational rate, that it should not matter whether I take that rotation rate at the bottom of a device or at the top of a device, especially a spinning ball. It would be the same whether you took it right on the globe or an inch above the globe. Would you agree with that?
Yes.
Okay, and you would be absolutely correct. It would not vary at all because it doesn't matter where you would be, high or low, on that same latitude line. It is going to rotate at precisely the same speed. Well, here's the problem with that. What we found was that when we did the measurement with the fiber optic gyro at the 4,000 foot elevation, we had about a 1.3, 1.4 degree per hour variance from that done at the 14,125 foot elevation on Pikes Peak, okay? So we thought, well, that's pretty interesting because that actually equates to be 26, 27 degrees per day, right? That's a huge number. So we did it again at a different place, Guanella Pass, and again, and again, and again. And we did it in several different places in Colorado. And again, each time we then went to its corresponding latitude line at a lower altitude. And every single time we got a greater than 1 degree variance on the two measurements. Well, why would that be? Well, if you think back to what I just said about how the luminiferous ether was always said to propagate, and this comes from the people that coined the term, Newton, Maxwell, Clerk Maxwell, all these people that talked about this originally, then all you have to do basically is visualize it as a vortex, i.e., like a tornado. Okay. So if you are looking at a tornado and you look at it on a z-axis, right, then at the top of the tornado, right, it's rotating fairly slowly. And as you go down that z-axis down towards the ground, it rotates faster and faster and faster, right? So you have a considerably faster rotation rate at the ground that you do, from high up in the air. Would you agree with that?
Okay.
Did I lose it?
I'm good with this. I've gotten more than halfway through. I watched like 3/4 of the video. I wish I was smart enough to understand this. I know somebody who is, though. And I know somebody who... I'm not necessarily affiliated with this person, but I know I can send this to him. This person. Fight the flat earth. I'm gonna take this. There we go. I'm gonna send it to Fight the Flat Earth. See what he thinks. Let's do this. Wait. Perfect. Kinda see it. Whatever. To it. That off. Here we go. Take a look at this. Okay, there we go. Now, insert the link. Authorization thing. Authorization. Yeah. Yo. What did I do here? Okay. Never mind. Okay, I'm gonna end it here. I've been going for a while. So yeah, I'm just gonna end it here. Thank you for watching.